Hello, this is the last section in Unit 4. It's the last time we're going to talk about quadratics. When we start Unit 5, it will be trigonometry. Let's put today's date and get started. Monday, May 25th. Using the Vertex Form to create quadratic function models from data. Goals: to determine the vertex form of a quadratic equation given a graph, to determine the vertex form of a quadratic equation given a table of values using a curve of good fit. We're going to be using the textbook question in example 2. So if you have your textbook, you want to turn to page 242. All right, so note number 1. When determining the vertex form of a quadratic equation, y equals a, x minus h squared plus k, you must know the a value and the vertex hk. Okay, so you need to know what these values are. They're all numbers. Okay, they're all numbers. Okay, so if you call this a vertex form, then it means that you need to use the vertex. Sometimes, like example 1, you notice that the graph does not touch the x-axis. And when that happens, you cannot use the factored form. The factored form does not fit because there is no x-intercept that you could sub in at all. Okay, so the only thing you could do is use the vertex and one of the values that go right through the corner of a grid square. Now, if you look carefully, you'll see that 3, 1 is the vertex. But then to identify another value in order to find the a in the vertex form, you have to look carefully. This part of the parabola does not fit or go through a corner of a grid square, okay? This does not fit a corner of a grid square. So the grid squares, right, are over here. Now, this could potentially work, right? And really, the question that you have in your own mind is, what point is going to be the most effective? Don't approximate a point. So, I mean, you could, I think maybe that's even a stretch to say that that's going through a corner, okay? I can very well say that this is the better point, okay? So that's the x value of 0 and the y value of 7. So I could say that this is point 0.07 is one of the values that go through the corner of a grid square, and that's what I'm going to use to find the a. All right. So let's start. So first thing we do is writing the vertex form. We're going to sub in the vertex. Okay? So sub in v equals 3, 1. Where 3 is h and k is 1. Y equals a, x minus 3 squared plus 1. I need to know the a value. To do that, I need to take a point on the parabola that also goes through a corner of a grid square. So the second thing is, what is a? I want to sub in a point on the parabola. Okay, so it's going to be 0.07, where x is 0 and y is 7. Okay. So x is 0 here, and y is 7. What happens is I rewrite the a. Now is my opportunity to know everything except the a. Well, then I solve for a. Okay, so then the third thing is solve for a. Okay, so I have 7 equals 0, or sorry, a equals 0 minus 3 is negative 3 squared plus 1. 7 equals a. Negative 3 squared is 9 plus 1. And then I want to write the 9a in that order so that my brain recognizes it. And I need to use SAMDEP. Okay, so if I know that 9 is multiplied by the a, the plus 1 though needs to move over. So the opposite of adding a for adding 1, the opposite is subtracting 1. So I have to subtract 1 on both sides. 7 minus 1 is 6. I have 9a. Between the 9 and the a is multiplication. So next to the m for multiply, I'm doing multiplication of 9. The opposite is dividing 9. So divide by 9 on both sides, and then I reduce, becomes 2 over 3. The last step is sub the a value of 2 over 3 into, and this will be the general equation that's here, y equals a, x minus 3 plus 1. So a is replaced with 2/3. Is the equation of the graph in vertex form. Now, pay attention to your a value. If it's positive algebraically, then it should be smiling and opening up. Okay? All right, let's do the next one. Example 2, complete investigate the math on page 242 and follow steps A through G. So we're going to use this introduction all the way to G, and then we're going to talk a separate question that's down here. Okay? All right. So it says, the table shows data on the percent of 15 to 19-year-old male Canadians who smoke. So there are the years and the percent. When we have a year here, we want to understand that time existed before this year, but the data itself did not exist, okay? So we could say that if we round down, 1980 could be our starting time where time is equal to 0. It might be more effective and more appropriate to say that time equals 0 in 1980, and then from there, the difference between 1980 and all these other years is going to be the value on our x-axis. In our y-axis, because the percent is resulting in the year, we want to look at what is the highest. So it looks like, well, 43.4 is pretty high. It dips low, goes to 22.6. It's coming back up. Looks like 43.3 is about as high as it will go. We do not want in a scatter plot to draw a set of axes that are broken, right? So we don't want to do a zigzag in our values. So 43.4, a pretty big grid here. So if we want to go, so the highest, the max is 43.4, the min is 22.6. So we've got a lot of values here that we can fit in. So if this would be 0, let's count the number of lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if we say that our max is, let's say 44, okay, divided by 20 lines, we could go up by 2.2, which is not very valuable. So what if we went up by 5s or even by 4s? Okay, so this would be 4, this would be 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, and we've reached our max there. Okay, if we wanted to, we could go up by 3s, which is very, very fine. Okay, percent, so percent of 15 to 19-year-old males who smoke, and this is going to be our year. So since 1980, okay? So if this is year 0, where year 0 is 1980, then we can go up. This would be 1 year 2-year, 3-year, 4-year, 5-year, 6-year, 7-year, 8-year, 9-year, 10-year, 11-year, 12-year, 13-year, 14. So 14 plus 1980 would be 1994. We have to go to 96. Okay, so years since 1980. Okay, create a scatter plot. So we have to create a selection of points from this table to represent the data. Okay, so in 1981, it was 43.4. I'm going to go like this. Okay, so 43. So that would be 42, 43, pretty high up there. Okay, so 93 would be here, and that would be 36. Let me see the data myself. $39.9. Okay, so 39.9 right there. So in 85, 26.7. Because 26 would have been half, so let's go up a little bit higher there. Okay, so where am I? So 25. 25.2. 1986, there's a bit of a gap there, so 86, 22.6, $1991 and 22.6. Those are identical. Okay, now 2 points do not make a flat vertex, right? So the vertex has to be a little bit lower than 22.6 when we draw our curve of good fit. Okay, so 94 at 27.3. 95, 28, and then 29, 29.1, not quite half, about, oops, one more over. Not quite. Okay, so there we go. So I think I was happy with that one. Thereabouts. Okay, these points are not perfect. Okay, we know that. But we want to pick a vertex and then draw everything coming off of the vertex. Okay, so we said that these were the 2 lowest points, so let's decide that this is going to be our AOS. Okay, so that's our AOS, so that's our H value. Okay, and then we're going to go a little bit lower, so it would be easiest to go like here and then widening out. Maybe even lower. Hard to say. Could we do a graph like this? Now, as soon as we draw one side of the parabola, see how this is exactly on the corner of a grid square? So count 1, 2, 3, 4, 5, 6, and then that many over to the right. 1, 2, 3, 4, 5, 6. That was not a point on the grid or on the table, but it's going to be a point on our graph. Okay? And then maybe even this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same number of spaces on the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, that was not on in our table, but it's going to be in our scatter plot and curve of good fit. Okay. What shape? So we've done A because this is our scatter plot. What shape describes? So the shape is a parabola. Estimate the coordinates of the vertex. So V equals 10 and 20. 10 and 20. And oops, move that over a little bit so you can see it. Okay, so use the vertex to write the equation in vertex form. So we take y equals a, x minus h squared plus k, where h and k are in the vertex. Y equals a, x minus 10 squared plus 20. Use the vertex to write the equation in vertex form. So that's where we do D. Okay, so we sub in the vertex, and then we sub in a point. So first, sub in vertex. Second, sub in point from curve of good fit. We could use this point if we wanted. So 436. To find A. Okay, so x is 4, y, so y is 36 equals A, 4 minus 10 squared plus 20. 36 equals A minus 10 squared plus 20. Move the 20 over. Okay, so 30, you know what, let's do this. 36 plus 20, and then 36 minus 20 equals A times 36. So we get 14 equals 36A, and then divide. We can reduce, take half. It's our A value. So therefore, y is equal to 7 over 18, x minus 10 squared plus 20. Okay, so that's our vertex form. All right, use the vertex form to write the equation. In what direction does the parabola open? What does it tell you? So an E opens up, therefore A is positive, okay? Therefore vertex has a y minimum. Okay. Using one of the points in the table, calculate the a value. We did that, so that was in here. So E, that's E. Write the equation in the vertex form and in standard form.